Number 12 and number 13 are essentially two versions of similar problems. You can see, you can visit page 8 in your notes, but they use this equation right there for both of them, where h is your height at the end, v of o is your starting velocity, and h sub o is your starting height, wherever the ball or whatever's moving starts. So, number 12, a lacrosse player throws a ball in the air from an initial height of 7, so we got a starting height of 7. The ball has an initial vertical velocity of 90 feet per second, so there's our initial velocity of 90. Another player catches the ball when it is 3 feet above the ground, so they want to know when it is 3 feet above the ground. How long is the ball in the air? So, we have our equation, we have our starting height, our h sub o, we have our starting velocity, which is our v sub o, and we have our final height, our h, our 3. So we're going to start off just plugging all those into the equation. So h is 3, so 3 equals negative 16t squared plus our initial velocity of 90 feet per second times t plus our initial height. Our initial height in this case was 7. And so this is our quadratic. Again, move everything to one side so we can solve. So I'll subtract the 3 over, so 0 equals negative 16t squared plus 90t. 7 minus 3 is 5. No, 7 minus 3 is 4. One of these days I will graduate from high school math and learn how to add. And you can just plug this straight into a quadratic equation if you want. I'll start off by dividing by 2, just so it's a little bit simpler. Negative 16 divided by 2 is negative 8. T squared, 90 divided by 2 is 45, and 4 divided by 2 is 2. Alright, so your initial equation is negative b plus or minus the square root of b squared all over minus 4ac all over 2a. Try to write a t there instead of plus or minus the square root of 45 squared, whatever that is, minus 4 times negative 8 times 2 all over 2a. 2 times negative 8 is negative 16. So I'm going to go ahead and just start plugging and chugging this through. So I got negative 45 plus or minus, and since this is a word problem, I'm not so much worried about reducing it, making it all nice and pretty. These are going to come out to big, ugly, funky decimals. So we're just going to multiply that whole thing out. And when I get my calculator, I get 45.7. And now we have to solve this twice, once with the plus and once with the minus. And we do, so negative 45 plus 45.7 divided by negative 16, and we get t equals negative 0.04, and then we do it again with the minus sign this time, negative 45 minus 45.7 divided by negative 16, and you get 5.668. So again, we're talking about a real world situation. So if you got your graph, a guy hit a baseball from 7 feet off the air and went way up and came back down, and so this is time. Can you have a negative time in a real world situation? No! So the negative 4 is out. You're left with the answer at time 5.668 seconds. The ball was 3 feet above the ground. Okay, number 13 is the exact same type of problem, but from a slightly different perspective. A gannet is a bird that feeds on fish by diving into the water. A gannet spots a fish on the surface of the water and dives 90 feet to catch it. The bird plunges towards the water with an initial velocity of 95 feet per second. How much time does the fish have to swim away? So, let's graph this out real quick. This is your height. This is the time. So basically what's going on is the bird starts off way up here at not 95, at 95 feet in the air, and he's diving straight down to the water. So his finishing height is going to be 0, because that's how high he is above the water when he catches the fish. So when I plug everything in, we're still going to get negative 16t squared plus, now your initial velocity, here's the other thing we got to consider. He's not going up, he's going down, so his velocity is actually negative. So instead of a positive 95 feet per second, we are going to put in a negative 95 feet per second. So negative 95 times t, and since we're starting at positive 90, that's how high in the air he gets. Oh yes, and we want to get all the way down to 0. So my final height in this case is 0. So for this one, there's really nothing to moving around. Your quadratic is already set up and ready to go. We just need to crunch the numbers. So negative b plus or minus the square root of b squared. Let's change colors real quick. So negative b instead of positive 95, it is negative 95. It is a positive 95 plus or minus the square root of 95 squared minus 4. Let's move that over a little bit. Times a, which is negative 16, times c, which is 90, all over 2 times negative 16. And again, this is a word problem. I'm not worried about this reducing all perfectly and everything, so I'm just going to throw everything in my calculator. I got 95 plus or minus. All that crunches out to 121.6 divided by 2a. 2 times negative 16 is negative 32. So again, we got to solve this twice. Once with a positive and once with a negative. So we'll do it with a positive first. In this case, time is going to equal 95 plus 121.6 divided by 32, and then 95 minus 121.6 divided by negative 32. And these are the two answers that you get. When you add, you get the negative 6.77. When you subtract, you get the 0.83. And again, we're measuring time, how long it takes to do something. And since when we're dealing with the normal realm of reality, we're not going backwards in time, so negative 6.77 is not the answer. So the time it takes for the gannet to land is 0.83 seconds. That is how long the fish has to fly away. That is an awfully fast bird.